Dear students, warm greetings to all. This is Professor Hariharan from Sourashtra College, Department of Computer Application. I'm going to deliver the topic of fundamentals of software engineering in this content. Let us see the fundamentals of software engineering. Right. Some nutshells. Software engineering is an engineering branch associated with the development of software product using well-defined scientific principles, methods, and procedures. The outcome of software engineering is an efficient and reliable software product. So generally we know the engineering approach is applied when we go for it to develop a concrete applications, so that we need to follow some scientific principles, methods, and procedures. So our outcome of a project is a well and quality one and efficient one and cost effective one. The IEEE defined the software engineering is the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. That is, the application of engineering to software. So it is nothing but a study of approaches as in the above status. We need to follow some procedures, methods, and disciplines when we develop a software, because the main aim and goal of the development of software is an efficient and it should be maintainable and long term. Let me discuss about something other engineering principles comparing with our software engineering, and what way the software engineering differs from others. Let me have civil engineering. They have a blueprint as a notation or the approaches to follow. And in mechanical engineering, they are developing some engineering concept in. They have a schematic diagram. But in a software engineering, we have in its infancy stage, because we don't have any developed, and what are the methods should be followed when we develop this type of software, and we don't have any particular choices. We can choose this method when you develop a particular software or different software. Okay, let us see some deep concern about the software engineering. First of all, we want to know what is a software and what is engineering. Okay, what is a software? Software is a program or set of programs containing instructions that provide the desired functionality. Engineering is the process of designing and building something that serves a particular purpose and finds a cost-effective solution to problems. So we know that it is a set of programs containing instructions that provide the desired functionality. A software is nothing but an step-by-step instruction to solve a particular problem in efficient and cost-effective way. Why we need this software engineering? Even though we are only dealing with the coding and static information of coding. Let us see. What is the need of a software engineer? Right. First of all, the need of software engineering arises because higher rate of change in user requirements, environments on which the software is working. Because the software is not our application is not a fixed one. Day to day, we need a lot of requirements, a lot of changes in requirements in our software. So we need to bring some methodologies how these changes can be updated in our software in a long time. The second one, the main factors that have resulted in the need of producing software products using structured method. Like, take a say, if suppose it is a large software, it is easier to build a wall than a house or building. Likewise, as the size of software becomes large, engineering has to be step in to give software a scientific process. Further, scalability. If the software process were not based on scientific and engineering concept, it would be easier to recreate new software than to scale an existing one. Larger system evolve from small scale ones to a database from a few tables to hundreds plus of tables. So this is the main purpose of following software engineering, because the software is in nature, it is a scalability. There will be no any fixed size of software. When the time is passes on, the organization or the governments or those who are developing in software, or those who are using the software, they need to extend the software in a particular extent. So the scalability plays a vital role. So we need to follow some procedures and methods. Then cost. So this is the major factor when we consider when we develop a softwares. As hardware industry has shown its skill and huge manufacturing has lowered down the price of computer and electronic hardware. But the cost of software remains high if proper processes are not adopted. We are all well known the cost of the hardware is declining every day for 9 months because of the mass production of your hardware. But as a software, we're getting in more complex and complex. When we're comparing the software and hardware costs, we need to invest more in software. That is dynamic nature. The next one, the always growing and adapting nature of software hugely depends upon the environment in which user works. If the nature of software is always changing, new enhancement need to be done in the existing one. This is where software engineering plays a good role. Yes. In fact, dynamic nature, because the software is usually depends upon the environment in which user works. We already know the requirements are always changing, so we need to update the software as on date. So that is called a new enhancement in the existing one. So we need to know what is the procedures, methods, techniques followed in the existing project. So we can easily update the software in the new environment and it can be enhanced in further future enhanced. The next one is quality management. Better process of software development provides better and quality software product. So software development provides better quality software product. Let us see what is the software life cycle. So the diagram itself represents, we can start that from, let us see here, you can have the first one, planning, then analysis, then design, then implementation, and the testing and integration, and finally we go for a maintenance phase. So this is the stage of a software cycle. So every stages there will be some techniques and procedures should be followed. So we can easily update it on every stages when we go for some additional requirements or existing requirements should be enhanced. So we have some ideas about this stages of a software. Yeah. Let us see. The diagram provides an illustration of the stages that a software production process goes through. Imagine any engineering product does go from an idea, the drawing board, that's to satisfy certain requirements. The product goes through analysis, design, and actual production. So this is the first stage. Now we are going to developing a software. We cannot start it from the coding. So we go for an analysis and design it and go for a further actual production. Initially, the software product is a concept that needs deeper analysis from abstract into concrete realization. Okay, considering. So we know what is the software, what are the stages of a software life cycle, and we have a many stages in software life cycle. Let us discuss about some size factors. So generally, these sizes can be segregated from on the basis of a size. Let us see this. You can see this in this screen. I have a minus small. The duration of the software to develop it 1 to 3 elapsed months, and the number of people is involved 2 to 3, and the cost is up to around 1 million. And the same we have a small and medium, then medium size, and medium to large, large size, and super large. So I have a different factors. Every project based upon this duration and people and cost, we are segregating as a whether it is a medium project or large project or super large project. So we need to follow what is the procedure should be followed in these project sizes, because when the project size is increased, the complexity of the project also increased. So we cannot be able to further enhances. Yes, students, let us see this diagram which representing the success rate of your project by its size. So it shows the success rate and the project size and what is the percentage of successful project and failed project. When you take a small project, we have a success rate is 62% and the failing rate is 11%. And then the next average project size, we have a success rate is 30% and the failure of this project is 48%. And the same in a very big project, the success rate is only 2% and the not success rate is around 17%. So comparing this, we can easily understand that the size of the projects plays a vital role in the success of your project. So we need to follow various methods and procedures and techniques when we go for a project size when it is going to be becoming a large. This is the same diagram. It simply implies that the project size when increase, the complexity of the increases. So like a small project, we have a little bit complexity, and in medium project, we have a middle level complexity. And when we go for a large project, the risk of the project success rate is very much affected by a project size. Okay. This is the end of a fundamental of software engineering, a concept of what is the software engineering, what is the definitions, and how the software engineering and why the software engineer needs to implement when they develop a software project, and how this project size affects the success of your completion of the project. Let we discuss another topics in our next e content. Thank you, students. Thank you.